Welcome to the second part of the customer management example, the simple customer management example. As I previously explained in the first version, in the first video, this version is going to separate the different layers more of an end-tier approach and more realistic in terms of how one of these products would be developed. Now, the end product is pretty much the same. Not a lot changes. Actually, nothing in terms of the GUI changes. What ends up changing is these three classes get created, where the data objects is the strict connection with the database. Business objects acts like a middle layer between the actual logic, which would be customers in this case, and data objects. Essentially, this is what we did. So in the first version, we had the GUI, and it's just really ugly, but you get the picture. And so as we saw, we did an add, we did an edit, we did a delete, but the database was directly tied to the GUI. So in this form, you saw the using system.data, and you saw the executing of the SQL statements and all that stuff. In the new layer, or in the new version, the second part, that's not going to be the case. In the second part, we're still going to have the same GUI. So let's just, for the sake of argument, use this as the GUI. Then we're going to have two other layers, three other layers actually. This one is called data objects. This one is called business object. And this one is going to be called customers. And your database is actually going to be connected directly to this layer. And the way that this works is this class uses business objects. Business objects uses data objects. And this is just to show an example of how you could interact between classes. In reality, you would probably want to inherit, and that way you don't rewrite a lot of the code. You could just reuse it. However, to show how inheritance would work, customers inherits business objects, and then this class, this form, uses customers. The connection string is here, and it gets passed down so that this understands how to communicate with the database. Now, the good thing about this part is right now we're using access. In the previous version, if we were to change this, a bunch of this code here would have to be modified. In this case, we would make modifications to this class and everything else works perfectly. So this is an example of a completely scalable solution. You could change this, you could grow the requirements, meaning you could go from access to MySQL and very little code would change. Essentially, your database components would be here. Then you would have some sort of helper methods and other stuff here. And then this would be completely centric to how the database looks. Now, in data-centric designs, this is typically going to be the case. So for example, customers and however customers are described, meaning having a customer name, an address, city, state, zip code, those attributes, those characteristics of the class are specifically around how the database was described. So how the customer table was described in terms of customer's ID, customer name, address. So these two look very similar. However, what populates those fields is this connection. And that's what we're going to work on now. So the first thing that I'm going to do here is separate the code, and I'll do so by creating a new folder, and I'm going to call it classes. And the first class that I'm going to create is going to be my data object, my data objects class. Students of my previous classes may notice that I named it differently, and understand that you can name this whatever you want. It doesn't really matter. Sometimes I name it data layer, other times I name it data objects. It depends on what I'm trying to teach at that particular moment. In this case, I'm just going to call it data objects, which is more realistic to what my naming conventions would be. So if we recall from part one, and we can actually take a look at it here, this layer had this access. Well, remember, based on what we saw here, this would no longer have that. It would be in this. So right off the bat, you know that this is going to shift. And it's going to shift into here. So we're going to say using system.data.oladb. And I'm also going to need a reference to system.data, which is what holds a data set and data row and so forth. So in this part, I'm going to need a variable that handles my connection, and I'm going to call it con just as I did before. I'm also going to need a variable for connection string, and in this case I'm going to add a new variable which is going to handle any error that could occur here. I'm going to call it extended error information. And the basis for this is any error that occurs in this class I want to capture and provide exposure to the classes that either use it or inherit it. I also want to get into the habit of creating some comments and maybe even adding some regions here. For those of you that have never used regions before, this is just a way of organizing the code so that you could collapse these with a label, and they're just easier to find. And when you have code that's very big, that extends pages and pages, you can compress these areas so that you can find things a little bit better and easier. Once I do this, I can create my constructors. And generally this default constructor should never be used, and the reason is I'm going to need to pass it a database, the connection string really, so that it knows how to connect to the database. So whatever I put here doesn't really matter. I can just set connection string either to pretty much any connection string or empty, doesn't really matter. However, I always get into the habit of creating a default constructor even if one is never used. And I can create the next constructor, which is the one that I will be using. And in this case, I set the variable to this, and I create a new instance of my connection. I will comment the code. And now I can create my properties. What these properties do is expose these private members to the outside world, or at least the ones that I need. And in my case, I'm going to allow connection string to be exposed and to be both set, well, this one is get, return, but I'm also going to allow users to set a new connection string in the case that they need to. If you don't understand these properties, you can take a look at another video that I created where it's more basic, more of an introduction, and it explains the concept of classes and the concept of properties and so forth. The next property will expose extended error information. And this will just be a read-only property, so it only has a get. And I'm also going to create a region for these. Now what I end up doing is moving the functionality that is related to the database. So for example, this I would move to this class because this is where this will actually take place. Obviously I'm going to have some errors that I need to correct. The first thing is this should be public now. This will still exist. This will still be true. Since I'm using the same variable names, most of this won't change. Pretty much nothing will. This, however, is no longer the case because you can't show a message box in a form. This is something that is specifically for forms. I'm sorry, in a class. This is specifically for forms. So instead, what I'm going to do here is I'm going to say extended error information equals ex.message, which is the exception. So it's then captured. Return is still the same thing because this is still the same return type, and my finally is also intact. Afterwards, I want to add a few methods that are going to help with data. So filling a data grid, for example, will need a data set, and then doing some other stuff will need a data table. So since I want to make this class as generic as possible and as usable as possible, I want to create all of this functionality within the class. Oh, but before I do that, let me comment my code. Alright. And now what I want to do is create this method that's going to return a data table so that it helps me with whatever requires a data table, and we'll call it get data table. And we're going to need to pass it an SQL string, and we're going to need to pass it a table name. And for all of these methods that require opening and closing a database or a connection to a database, we're always going to do this TryCatch. And pretty much whenever you're using code that can potentially cause an error, you always want to use a TryCatch. Just common practice. So we're going to create a data set and we're going to call it DS and create a new instance of that by instantiating it. And we're going to create a data adapter, and we'll call it adapter. And we're going to instantiate this as well. And this requires an SQL command, which is what was passed. And it's going to require a connection, which is over here in my constructor, right there. So I have both of these. Neither of these will generate an error, so we can keep these outside. However, opening up a connection can definitely generate an error, so we want that within the try. And then I want to fill my data set using that adapter, and we need also the table name, which is passed, so it's right there. And if you recall, this is very similar to that select statement that we used in part 1. So the code is very similar. And now I want to create a data table. We'll call it DT, and we're going to set it to that table that we already know, table name. And now we could just return DT. So if all is well, this will be returned. If not, then we're going to populate extended error information with whatever error message is returned, and we're going to return null. And prior to finishing, we will make sure that our connection is closed by doing this. So the next class is going to be relatively similar. What it's going to do is it's going to return a data set, so it would return this. So as you can see, it's very similar to this. So what I want to do is just copy this and change the new stuff. So I'm going to call, first it's going to return data set, so we change the return type, and then we can just name it data set. It receives the same information, so that's not a problem. We're going to fill here, so that's not a problem, but we don't need this. Instead, we return DS, which is a data set, and that's pretty much it for this. Everything else remains the same. And before you continue, remember to comment the code. So this returns data from database table, and this is SQL query, name of the table, and it returns data table containing data. And you're pretty much going to do the same thing here. Gets data from a database table, and parameter would be SQL command, name of the table, and this returns data set containing information. Lastly, I want to incorporate some way to find. So a find function. This can be expanded later on. For now, I want whoever's using this class to be able to find something using an SQL query, and it returned the row containing that. So realistically, it would just be one result. It wouldn't be a result set. A result set would be returned in either a data set or a data table. This would do a multiple find, meaning you have a set of data. Let's say you're doing select asterisk from customers. It would return the entire bit of information. However, if I needed something to only return one record, meaning select asterisk from customers where customers ID equals this specific number, then in that case you wouldn't want to return a data set or a data table. You would want it to return a data row, which contains only that unique row, that unique data, that piece of information. So the return type is going to be data row, and let me call it find by SQL, and it's pretty much the same information that I've had in the other ones. String table name, and so what we can do is just copy this and then change the specifics, and the specifics in this case would be, I would need to create a data row, and we'll call it row. And data set is fine, and data adapter is fine. I'm going to need both. I'm also going to need to open. However, after I fill this, what I'm going to do is set my row equal to the result of the table, the name of the table, so table name, dot rows, and then just the first one. And this is zero index, so it would be 0 would be the first one. So it would be this. And then I can just return the row. If an error occurs, fill this and return null. And finally my connection should close at the end. So as you can see, all of these are very similar. And go ahead and fill that out. All of these are going to be very similar. One returns a data set, one returns a data table, the other one returns a data row, but they all return data. And all of these, for example, represent what we did in the previous part, which is here. Either selecting, updating, inserting, or deleting. But in our case now they're set to only this class. So execution would be insert or update, and then these would be obtaining data. The next class that we're going to build is going to be called business objects. And this class really is a helper class between the database object and my logic object, or customers in this case. It's basically going to build on the functionality of data object and extend this. Generally, we would inherit this class and build on top of it. For this example, what I want to show is a different way of doing it. Not necessarily it's a better way. It's just a different way so that you can see how you use classes and expand on these without inheriting. And then when we do customers, you'll see how you inherit and build on a class. So I kind of want to give both examples, which is why I chose to do it this way. So this one will need access to system.data, which is the general namespace for handling information or data. So this has data set and so forth. However, notice that this does not have a reference to OLEDB. And the reason is this class doesn't care. This class does not understand that part, which is completely separate from the data layer. And we're going to create a couple of private variables, which includes access to data objects by creating a reference to that object. Some of you might be wondering why I do this, why I have an underscore when I do private variables. So let me just show you here. So here. And the reason that I do this is it's more a company practice for the company that I have. And it's a way that we distinguish when a variable is a private variable and then has a property that's called very similar. So if I was to write a property for this to expose connection string, it would be capital CONN string, but it would be called practically the same thing without the underscore and with a capital C. That's why we do it this way. It's just for readability. Our whole thing is anybody who reads our code should be able to quickly understand it without having to figure out, okay, what does he mean by this variable, and having to go, search and dig through code all over the place. This is what you see is exactly what it is. All right, so we will create a variable for extended error information. And again, this is similar to the data objects. Now, if we were inheriting this class, this information wouldn't be there. It would basically be a duplicate, which is the good thing about inheritance is you inherit all the other stuff without having to repeat. In this case, because I'm doing it a different way, we are repeating. Again, not the best way possible, but it is a different way. It's got its set of advantages, but generally we would just inherit this. I'm going to create table name, which is the name of the database table that this revolves around, and data row, and now we can do our constructors. So I'm going to build a default constructor, and this constructor just sets data objects equal to the empty one, and then we can do the other one. Actually, the lazy way of doing it is just copying and pasting, and in this case this one is passed a connection string, and so in this case I pass it that same connection string. One thing that I do want to note is just because here I'm not focusing exclusively on the writing of comments does not mean that it is not important. Because I'm trying to demonstrate this as quickly as possible so it doesn't become a 2-hour tutorial, I'm limited in time. Nevertheless, you should always be commenting every single aspect of your code so that anybody that is reading this understands what it is that you're trying to do. It is very important to do so. Okay, what I want to do now is create the properties for these variables. So I'm going to start with extended error information. And this will just be a read only. Same thing with connection string. Oh, that's right. In this case, my connection string would be what is stored in data objects in this one. So when this got created, it passed a connection string, and what I want to do is return that connection string on a read-only property. And then data table, and data table name. This is what's going to set this whole table name, and this is why I say this is very data centric. And so in this case it would be customers, but let's say you were doing vendors or inventory products, whatever object that you're trying to create, the database table associated with those with that information would be set in this part. And lastly, I want to expose the data row, and this should also only be a read-only property. I also need a way of exposing those other methods that I wrote in data objects. So in this case, get data table and data set and execute SQL command, all of that, I need to expose it to this and to whoever's inheriting this. And so in that case, I will do data table get data table, and I'm only going to use SQL, string SQL, and the reason is I already know what the table name is here, so I can call it differently. And what I mean by that is in this one, DT, let's call this DT, data objects, when I call get data table here, I'll pass it this SQL command, but I'll also pass it the table name that is within that property that I have here. And I could have done this also. It doesn't really make a difference here. And so in this case, if DT happens to be null, that means some sort of error occurred. So I want to say extended error information equals data object dot and that property for extended error information, because it means something went wrong. And otherwise, I want to return that data table to the outside world. And we're going to do virtually the same thing with DataSet. So I'm just going to copy and paste and then change the required stuff. So the return type is DataSet, and obviously this changes to DataSet. And in this case, this would be get DataSet from that. This is DataSet. We'll change this to DS and change this to DS and also change this to DS, and everything else pretty much remains the same. So this gets the data table from the main object, data object. This gets the data set from that main object. And now we can do the same thing for executing the SQL query, SQL statements. And we can do that by calling public bool execute SQL statement, and this would accept an SQL string. And really all this does is just does a return data object.execute SQL statement with that SQL that was passed to this method. And last but not least, we're going to do the same thing with that find function. So we're going to call this one public bool find by primary key, and we are going to accept an ID. That would be the number, the actual value, and then a column name. And the reason I do this is I want this to be as generic as possible. This is a helper function, and this helper function should work with customers or with whatever object we create that inherits this. And so if you think about it, I can do select asterisk from, and I need the table name, which I have as a property, where, and then I need to know the column name for that primary key. So in this case it would be where customers ID, but let's say we had a different table with an ID of inventory ID or products ID or vendor ID. In that case I could specify the column name and the value, so I could build the entire SQL query with just these two pieces of information. And so I can set the row equal to data object dot and that find function that I had created with a built SQL query. And I'm going to build the SQL query by stating select asterisk from, and with that space, plus the name of the table, plus, and concatenate it with the piece of the SQL query that says where, and then give it a space, and I need to know the column name, which I have right there. So call name and concatenate the equal sign, and then give it the value. And this method requires that I pass over the table name, so I do so. And this will set the SQL, so it'll end up, in this case for customers, it'll end up saying select asterisk from customers where customers ID or whatever is passed here equals, and then the value that I'm looking for and the table name. Now once again, if row ends up being null, oh actually, like if row ends up being null, then what I want to do is save that extended error information that data object has and return false. Otherwise, I want to return true. And this pretty much does it for this class. So this helper class finishes up the functionality. Notice this does not know what type of database technology I'm using. It could have been SQL Server, it could have been MySQL, it could have been Oracle, it could have been whatever. Does not matter. This one does not matter. This one is the one that does data objects. Remember commenting the code on all of these. So add the comments. Just because I did not does not mean it's not important. In my case, time constraints for creating this video, but in your case, you can. And also remember that you can always add the regions. So I can say, for example, call this public functions, and then let me end the region here. And so as you can see here, it's easier to find, and then I can do so for these properties. Pound region properties, and I can end the region here where the properties end, and same thing. So as you can see, everything is very easy to find. If I'm looking for a public function, okay, it's in this section. I'm looking for a property, okay, it's in this section. And notice that if I hover over, Visual Studio even gives me a preview of the code that is in that section. So it's very useful. And so what I want to do now is create the Datacentric component, which is going to be the customers class, which is going to center around the database that we have. So the database information, the class information is obtained from the database. So I'm going to add a class, and I'm going to call it customers. And customers will also need a reference to data, but notice that customers does not need a reference to OLADB because it doesn't care. Customers, in this case, to show you how inheritance work, will inherit business objects. So in this case, I'm going to create the private variables, and these private variables are going to revolve around how the data looks. And so once again, if you look at how the database was designed, this should specifically represent how these variables are going to look. So I'm going to have a long for customer's ID, and this is going to hold the primary key, and everything else in this case is going to be a string. So customer name, private string, phone number, private string, address, private string city, private string state, private string zip code, and finally private string email address. Now this class can also contain its own set of errors, which I want to expose to whatever class or object is using this. And in this case, the user interface level would be using this class. And so just in case, I want to create an extended error information for this as well. And I can create my constructors, and I'm going to have my default constructor. Again, I'm just in the habit of doing this. You may not do it, and that is perfectly fine. I want to have a way of clearing all the fields, and so I'm going to create a method that does that. And I'll just have Visual Studio do it for me. And this is just going to set everything to either 0 or null. And so I'll have every single item here. Customer name, customer ID, email address, phone number, state, zip code, and is that it? Email address, phone, state, actually address. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And so I have city missing. So city. Anyway, you're just going to go through all of them. And so clear fields here. However, important, table name has to be set. So this will be the name of my table in a database. And in this case, it's going to be customers. Once again, be very careful with the spelling. If you misspelled this in your database, you have to misspell it here or either correct it, one of the two, but these have to match, otherwise you will get an error. And my next class is going to be very similar to this, so I'm just going to copy paste for in the meantime. And this will receive a string with the connection string, and it's going to call the base class with that connection string, and everything else will be the same. Afterwards, I'm going to create a property to expose every single one of these to the outside world. And to save a little bit of time, I'm going to copy paste. This is pretty much the same thing that we've been doing over and over again, except this time I have to spell this correctly. Alright. And so I have the property for customer ID and for customer name, address, phone number, address, and again, nothing different than what we've seen. Returns the private member and sets the private member with the value. City, state, zip code, and finally email address. So once we have all these properties created for each of these private members, then what we're going to do is generate the other code. Now remember, this code is going to replace a lot of the stuff that we have in the GUI, and we're going to start by loading the members. And so if we think about private members, load private members, and let's call this load private void load members. And it's going to accept the data row. It is going to be very similar to what we saw on the GUI. And let's look at the GUI real quick. So when we loaded this, it was in this form. And it was when the end user hit edit, we had the customer's ID or the primary key. We found the information and then we loaded from the database to the GUI. So it's going to be very similar. So if we look, if we look over here in this load fields, it's going to be very similar. Now the difference is we're going to have this data row passed. So this stuff is going to be where where we do it. Now notice if you looked at part 1, I did the try catch. In this example I did the if else, but it's going to be pretty much the same as this. And so we're going to be replacing this. And so if we go here, and I'm going to use a try catch. So we're going to say customer's ID equals long.parse row, and then the name of the row, which in this case is going to be customers ID dot toString. And so if this is good, then it'll load here, else it's going to catch an error, and we'll just set customers ID equal to 0. And we're going to do this for every single field. And so because most of this is the same, I want to do a copy paste here, and we'll do address and address, and in this case address is not a number, so we'll do empty. And because it's not a number, we don't need the long.parse, but we do need to change this to address because that is a field. And once again copy this, and now we do city, and change this to city, and this will be city. And continuing down the row, oh look, this would have caused an issue. City. This is where we have to be careful. Any little misspelling here and it will cause an error. Phone number. Now, the order of this doesn't really matter, is of no importance. In my case, I'm doing alphabetical order just because of the way that I name the variables. It's a little bit easier, but it does not really matter. By going in alphabetical order, I make sure that I didn't miss any particular variable. So in my case, it's a little bit more important. So that's it for the load function. The load method would receive a data row, and it would load accordingly all of its specific fields. So now we can continue on with the rest of the code. Once again, load members is set. And now what I need is a way of loading the entirety of the data. And so what I'm going to do here is create a function called getAll that returns a data set. It does not need any parameters because all of the information is known, but I do need a TryCatch just in case some information is not there or some error is returned. And in this case, DataSet, we'll call it DS, is going to be get dataset. And again, I can do this because I inherited the business object, and so now I have access to its public functions or protected functions. So I do have get dataset, which I call, and I pass over an SQL query, which is going to give me everything, and then I return that dataset. If by any chance an error did occur, then that error would be an extended error information, which again I have access to because I inherited that class, and I can return null. I can also foresee what possible methods I may need. And one of the methods that I probably will need is a way of finding a customer. And I can think of finding by an ID, primary key, or finding by a customer name. So I can say public dataset find by customer name string cust. Now you may be wondering why, if I did find by customer name, I'm returning a data set. And the reason is customer names may not be unique. Two people can have the same name. Therefore, if I do the if I find I'm sorry, if I use that function, which was find by SQL, from the data objects portion, which returned a data row, it would force a return of one and only one record. Instead, dataset can return 0 or n number of records. That's why I use this version, the dataset version. And this is going to be pretty much the same as the get all, except that I have a more specific SQL query. And in this case, it's that I have a customer name. So I can do select asterisk from customer name, and then I can add the where clause. Where customer name is equal to, or actually instead of equal to, I can say like. And what that does is it allows for me to use a wildcard character, where if I enter a portion of the name, it'll look for that. Plus cust plus, and the rest is pretty much the same. Return this, nothing out of the ordinary there. And now I can do my find by ID, which is that primary key, and I'll use a long for that, and I'll call it L number. And let me declare an SQL query, which would be select asterisk from customers where, and that primary key, which is customers ID, equals, and as always, be very careful with the spelling, and data table, I'll call this current data table equals, and I'm going to use my get data table that was inherited and pass it over an SQL query, which I have right on top, and then declare a data row, and we'll call it row. And if my current data table is not equal to null, then what I want to do in that case is load the row. So my row is going to be equal to the current data table, the first row of that data table, and then I'm going to load my members. So I'm going to call that load members function that accepted a row, and there's a row right there. So this will load the results into the specific properties, into the specific variables that are then exposed by the properties which the GUI, the user interface, will end up using. And then I'm going to return true. Otherwise, I'm going to return false. And that'll take care of that method. So up to now I have a find and I have the load all, which is the get all. So what I need to do is add the functionality for the add, edit, and delete. And add, edit, and delete are going to be very, very similar to what I've already written in the GUI. So I'm just going to move that into my customers class and take that out of the GUI. It should not be in the GUI when I have this type of separation. So let me create a method called public bool add, and I'm going to go into my GUI where the add function will be, and there it is. That's my add customers. So I'm going to copy this. Eventually I'll delete this, but for now let me just do copy so it doesn't give me a bunch of errors. And I'm gonna go into here and I want to modify accordingly. So the first thing that I want to do is set my string, set my SQL, which is going to be exactly the same thing. This does not make any difference. And then I'm going to delete this, and I'm just going to say return execute SQL statement, SQL. And I'm going to edit this stuff. Obviously, because I copied and pasted it from the GUI, it's got the properties of the GUI. But what do I know about txt customer name? Well, this is held in this customer name. And then address is held in address, and so forth. So I just replace one by one. And there I go. So if an error occurs in the SQL statement, it'll just return that from this and a false, otherwise it'll return a true. And then edit will be something very similar. So once again, I'm going to go into here and I'm going to copy and paste this and add the functionality for an edit. So it would be public bool edit, and paste that information. We can take this out and say return SQL statement. Oh, I deleted that by accident. And once again, I want to update, instead of using the GUI elements, so customer name, address, city, state, zip code, phone number, email, and this is actually called customers ID. And so that will also function pretty much the same way as this. Execute SQL statement with an SQL command. If this fails, it will return a false from here and then return a false from here. Otherwise, it'll be good to go. And the delete will be a straight up copy of the same thing. So of all this stuff, except this time it's going to be a much simpler SQL query. So public bool delete, and so instead of all this, this will just say delete, it should be in here, delete from customers, where customers ID equals and the customer ID that I need here, return SQL, and there we go, and that is my delete. So while this may seem like a lot of work, in reality, these two classes, data object and business objects, are going to be used over and over and over again for every single object that I want to add into a project or into a customer's project. So vendors, I can reuse this. Products, I can reuse this. I can create an invoicing system, and these two things will be reused for every single time. So you write it once and you reuse it a bunch of times, which is the whole purpose of this type of programming. So once I have these classes are ready to go, I can start updating the GUI to use this. And I'm going to start by updating my add edit form, add edit customers form. And in this case, is new I'm still going to need, was canceled I'm still going to need. I'm not going to need any of this. So I can say private customers. Oh, I need to actually add a reference to these things that are created. So now what we're going to do is eliminate all the OLADB stuff and create an instance of our customers class that's going to replace all of the other code. The one that isn't, that one that is tied to the GUI that shouldn't be tied to the GUI. So this stuff will not be necessary. And I'm going to create a new instance of customers with the connection string that's passed. Is new and was canceled is still the same. Now the only difference is here, before we load, we need to be able to figure out which customer it is. So we're going to be using it here. So we're going to say customers dot find by ID based on that method that we created, and pass it along that customer ID. And so this part will work perfectly here. Then in our load fields, we don't need all this stuff anymore. All this disappears. We definitely don't need close, because again, this has nothing to do anymore with the database. And then we load each one, txt, the GUI components, but we load it from our class. The rest remains the same. copy this. Add is no longer needed, and edit is no longer needed. Execute SQL statement is no longer needed. So we're going to delete all of those. Clear fields is still useful, but we're going to need something new, which is going to be save fields. So I'm going to create private void save fields. And this is pretty much the opposite of clear fields or load fields. And what it's going to do is the opposite of this. So this time these properties are loaded from the GUI component. Clear fields is the same, cancel is the same, and then this changes a little bit. What I want to do is call save fields. Whether it's an add or an edit, I would need to save the fields. And then if it's new, I want to call customers.add. And if it's edit, I want to call customers.edit. And that's pretty much it for the modifications of this field. Notice how simple this ends up being. And it has no idea what type of database or anything like that. It is completely separated from the database section. So now we change the code from form main so that we don't need the direct database components. So this, for example, is eliminated. And in this case, we can delete pretty much everything that has to do with the database connectivity. And we'll create a new instance of customers here as well. And to do that, we actually need to reference the classes, and now we can. So private customers, and we no longer need this. We can say customers equals new customers and pass that same connection string. And these two remain the same. This time in load database, in load customer data, we don't need anything that has to do with the database object, and that includes the close. And instead, here we would call customers.getAll, which returns a data set that contains all of the information in the database as we wrote the code before. And then in this case, we could say this is equal to customers. In reality, we could even say this is equal to customers.table name, as that property obtains the information of the database table. Exit remains the same. These which set the database, the data grid, remain the same. That has nothing different. And then these will pretty much remain the same. These don't change at all. Delete will change, because if you remember, this has a lot to do with the database. All this stuff is pretty much the database on that. Result we're still going to need. And if the result equals yes, then what we want to do here is say customers.delete and then load that. And that's pretty much it. One thing that we do need is to be able to find, before we call this, we actually need to find it. So we would have to say customers dot find by ID, and we already know the ID because it's here. It would be temp ID. And now this code should be ready to go. And so as you can see, this is completely disconnected. This has nothing to do with the database at all. Customers is here, and we use these objects, and a full disconnection is achieved. So now we can test this code, make sure it works. And so let's add a test object. And there it is. And let's edit. And there it is. And let's delete. And we test the no. And then we test the yes. And there it is. And so as you can see, this code completely disconnects one section with another, complete end-tier application. If you have any questions, feel free to write them on the comments section or email me, and I will try to get to you as soon as possible. Thank you for watching.